Okay, hello everyone. In a new video, on this one we are going to solve an exercise related to electricity in the chapters of DC voltage resistors, the voltage of the mains. This exercise was the previous one in the brevet exams in 2020 first session, exercise number 4. Now the title of this exercise is suitable wire in a circuit. Consider the three different electrical wires A, B and C of different cross-sectional area as shown in document 4. Then they mention document 4, now we can use it. A lamp acting as a ohmic conductor, it's a resistor, then we can directly apply Ohm's law to it. Its resistance is given by 10 ohms, then let's write this down. And a DC source, G of adjustable value, then this is important because we know that whenever the source is of adjustable value, then its symbol is given by that. From 0 to 24 volts. An electrician wants to choose the suitable wire to connect the lamp across the G, neglect the resistance of the wire. Now, number 1. They are telling us to draw an electrical circuit showing G the lamp and the connecting wires. Then let's start by the generator. Now, remember the thing that I mentioned here, so if it is of adjustable value, then we need to place this arrow. This is the generator G. Here I'm not gonna place any voltage because yet it's a variable from 0 to 24. Now these are the connecting wires. And here we still have the lamp since it's mentioned here. Then let me say that this is the lamp L. Now this is it for number 1. And number 2, they are telling us G is adjusted to the voltage U1 is 12 volts. Then let me place this here. Now always it's a good habit to write the voltages on the electric circuit. Now in 2.1, they are telling us indicate the value of the voltage across the lamp, justify your answer. Notice that here the lamp is the only component across in the circuit and it's parallel with the generator. For this reason, if this is 12 volts, then this is gonna be 12. Then let me say G and L are in parallel. So we need to mention the grouping. They usually give it half a mark. Then let me say according to law of uniqueness of voltages. They have the same voltage. And in this case, the voltage of the generator is equal to the voltage of the lamp is equal to 12 volts. Then we have that the voltage of the lamp is equal to 12 volts. Now we can place this here. Now in 2.1, they are telling us to determine the current passing through the lamp. So since we have determined the voltage and we know its resistance, then the current, one of the ways to calculate the current is using Ohm's law. And as it happens to be in this case, then let's say apply Ohm's law to L. And Ohm's law is given by the relation U is equal to R multiplied by I, and we are interested in determining the value of I. Constructing the triangle of this formula. Here, because we have multiplied, then U will be at the top, R and I at the bottom. We are interested in determining the value of I. So covering the value of I, then I is given by U divided by R. Now this is the voltage of the lamp, so let me say that this is UL, and R is denoted by R. Now the voltage is given by 12 and the resistance is 10. Plugging this fraction on the calculator is given by 1.2. Since both the voltage and the resistance are expressed in the SI, so the value of the current is expressed in the SI. Now let me say that this is the current I1 and is given by 1.2 amperes. Then let me make some space. Okay, I will keep the circuit and I will erase these. Okay, this is it for 2.2. Now in number 3, they are telling us to choose from document for the most suitable wire for this circuit, justify your answer. Now we know that the current traversing the circuit is given by 1.2 amperes. Now if we refer to document 4, now this consists of 3 columns. The first one just indicates which wire we are working with. Now don't worry much about the cross-sectional area, so just ignore this part. Now for each wire there is a maximum allowed current, so this is 1, this is 1.5, and this is 2.5. And whenever we are working in electricity, and we have a certain value, whether it's a traverse current or an applied voltage, always the most suitable will be the value which is slightly greater than this. So this concept appears another place, for example, like the most convenient scale, or for example, whenever we are choosing the most convenient circuit breaker. Now this is exactly the same. So 1 should be eliminated because this wire can handle only 1 amperes, whereas the traverse current that we want is given by 1.2 amperes. Remember that we are trying to build a circuit that is being traversed by 1.2 amperes, so we need to choose these wires that will be suitable for such a lamp and such a circuit, when the voltage for sure is given by 12 volts. Now since this is being eliminated, this works and this works, but this is more convenient since it's slightly greater than 1.2 amperes. Then let's justify and say the most suitable wire is the one having. Now here they are referring to the maximum allowed current, so let's use this. Slightly greater than the traverse current. Then in this case, this is given by 1.5 amperes and our choice would be wire B. Now in number 4, they are telling us G is adjusted to a new voltage 24 volts. Then we should erase this and this as well, because whenever we do an adjustment in the circuit, especially the battery, everything changes except for the resistance. Now this would be 24 volts. Now the voltage is doubled, so U2 is equal to 24 volts, and this is it. They are telling us to show that the current becomes 2.4 amperes, and this can be done again using Ohm's law. Then 4.1, apply Ohm's law to L. Now repeating the exact same steps, we have that U is equal to R multiplied by I, and we are interested in determining the value of I. Then constructing the triangle here, we have multiplied, and U will be at the top, R and I at the bottom, covering I. Then I eventually, which is given by I2, is given by U of the lamp divided by R. Now U of the lamp, similarly here, because they are in parallel, then they have the same voltage, then it's given by 24 divided by 10, which is equal to 2.4. Since everything is expressed in the SI, then the value of I2 will be in the SI, which is amperes. Then the current I2 is given by 2.4 amperes. Now in number 4.2, they are telling us the chosen wire in part 3 doesn't withstand the new current Y. In part 3, our choice was given wire B. And recall that here the maximum allowed current for the wire B is given by 1.5. However, the traverse current that we have calculated in 4.1 is given by 2.4. So in this case, we can say that since the traverse current is greater than the maximum allowed current, then the chosen wire in part 3 doesn't withstand the new current. Then let me write it down. Since the traverse current is greater than the maximum allowed current, and this is simply because 2.4 amperes, which is greater than 1.5 amperes, then wire B does not withstand the new current. So this is just a rephrasing of 4.2. And finally, in 4.3, they are telling us name an electric component that can be used to protect this electric circuit against overload current. Now here one could say, okay, we can use a resistor, but remember that, okay, resistor can limit the flow of the electric current, so we can decrease the current, but actually the component that protect from overload current in a DC circuit is a fuse. So the answer would be the fuse. Now remember that also circuit breakers can do such type of protections, but remember that circuit breakers are used in an AC circuit, and usually the currents has values greater than such values, like starting from 5 amperes and above. So usually whenever we have a DC circuit and we have an overload of current, then the electric component that can protect against overload is given by the fuse. Then that's it for me in this video, guys. See you soon in a new one.